Okay, again, hello everybody. Good morning and welcome to this webinar. Today we're going to talk about filter media. We're going to start with a video today. So enjoy the video and then I will be back after the video. Let me first go through the key takeaways of this training. Discover the filter media insights from a top performer and master the real meaning behind efficiency and beta rating and use it to make smarter decisions. Get an exclusive look at today's NanoNet technology and the innovations coming next. So first, we're going to start with why is filtration necessary? So why is filtration necessary? Well, filters or filtration help to prolong or extend the life of an engine. It's doing that by removing the unwanted contamination that can cause premature wear on these critical engine components, like the high pressure fuel common rail system. With filtration, we have a healthier engine equals fuel breakdowns, lower repair costs, and more money saving. So why is filtration necessary? We're going to look at filtration a little bit closer. I'm going to show you another video with a subject about air filters, efficiency. It's actually all about protecting the equipment using quality filter media.
Filtration, down to the science. Today, we're talking air filter efficiency. Filter efficiency ratings, 99, 99.9, 99.99%. They're pretty much the same, right? Wrong. Each filter is rated to perform in specific equipment applications and with particular types of contaminants. Using improperly specified or low-quality filters to save a little money can have long-lasting and potentially costly consequences, like lower torque and horsepower and poor fuel economy, all resulting in a shorter equipment lifespan. That's a high price to pay long-term for a small savings short-term. You get what I'm saying? Using properly rated, high-quality filters for your specific equipment and application ensures you get the performance and protection you need to stay productive and profitable. Fleetguard filters offer unmatched media technology to protect your equipment and keep you going. Why? Because when it comes to filters, small things make all the difference. Run cleaner, longer with filtration science.
The video talked about contamination and efficiency. Let's start with explaining contamination. Where is contamination coming from? Well, the first type of contamination is self-generated contamination. This is a result of normal engine wear and engine component wear that occurs over time. The second type is built-in contamination. These are the left behinds within an engine because of the engine or engine component manufacturing or even rebuild processes. The third and the last one is ingested contamination. Particles enter an engine from an outside source. All these types of contaminations must be filtered out. Filtered out from the different engine systems. But of course, the same applies to other types of applications or systems, like an hydraulic system or tank air breathers. Besides contamination in air systems, like this one, other engine systems are also or do also need to be protected against contamination, for example, fuel systems, oil systems or lubrication systems, and coolant systems. This slide is about the types of contamination that we will see in the different systems. In air systems, we mainly see dust, dirt, and sand. And this is what we also can find in fuel systems. Besides dust, dirt, and sand in fuel systems, we also see water, microbes, and additives in fuel systems. In the loop system, we will find, besides dust, also wear metals and oxidizing oil, sludge. So poor filtration or low filtration media quality, not efficiently filtering out contamination, can cause unwanted engine and engine component wear, and that results in failures and high TCO, total cost of ownership. Talking about TCO. This slide shows an iceberg. And this iceberg is an example of what the total cost could be because of poor filtration quality. A part of that total costs are the repair costs. The costs that are shown or that we see on the invoice. Component costs, but also labor costs. But another part of the total cost are the hidden costs. Let me give you a few examples of costs when poor filtration media quality is used in for example, air filters, fuel filters, lubrication filters that are causing high TCO. Air filters. Air filters having a poor filtration media quality that results, for example, in a catastrophic engine failure. The engine needs to be replaced. For small to medium-sized engines, we're talking about $6,000 to $18,000. If we only need to replace a component instead of an engine, for example, a turbo, we're talking about $4,000 to $5,000. Something totally different in cost. Fuel system component damage to injectors or fuel systems because of poor filtration media, $8,000. And I'm not even talking about engine components, repair, replacement, or after treatment damage costs. The last one is the cost of resulting due to poor filtration or a cheap lubrication filter, $11,000 to $12,000. Now, besides the repair costs, there are also the hidden costs for the fleet owner or for the company. Hidden costs, for example, standstill of the machine, the cost for the downtime of the operator, cost involving reputational damage, or cleaning costs. So the big question actually now is it really worthwhile to compromise on filters? Today's engines require quality filters that are capable of filtering out the smallest contamination particles. But how small is small? With today's engine technology, we are talking about micron size small. So this slide is about micron size small. We're looking at 6 to 4 micron here. These size particles can destroy a high-pressure common rail fuel system, and we cannot see these particles, 6 to 4 micron. But these very, very small particles can cause severe engine damage. We're talking about bacteria size small, micron rating. For your information, 1 micron is 1/1,000,000th of a meter. So it's very, very small. Now, with having the contamination explained and the possible cost and the micron, when poor quality filters are used, let me now move to explain efficiency and beta rating. I'm going to start with explaining efficiency first. So the air video talked about 99, 99.9, and 99.99% efficiency. But what does this terminology mean? We're going to use this example. What we see here is the filter and the inside of the filter. This is the filter media. And with this example, the media pores is 10 micron. We have the inlet side of the filter, for example, a gas or a fluid like fuel gas, LNG, or air, oxygen, or fluid like fuel, containing dust or sand or dirt or microorganisms like we discussed with fuel. And the inlet side is also called upstream side. And we have the outlet side, which is the downstream side. If we present 1,000 particles of 10 micron each upstream, then the efficiency is the ratio between the number of particles captured by the filter media, that is what we see here, and the number of particles presented upstream, the 1,000 particles in this example. So the air video talked about 99% efficiency. What does this mean if we present 1,000 particles upstream? Then 919 particles will be captured by the filter media. 990 particles. With 99.9% filter media efficiency, 999 particles will be captured by the filter media. And if we present 1,000 particles upstream with a filter media efficiency of 99.99% efficiency, then 999.9 particles will be captured by the filter media. Where do we see this terminology? Mainly on air filter data sheets. That is what we see here. So what is beta rating? I'm going to use an example of beta 10 equals 20. That is what you see here. We're going to use the same setup. Inlet, upstream, downstream, the outlet, the cleaner side of the filter, But we're not going to look at the captured particles in the filter media. And again, with 1,000 particles presented upstream and then 50 particles downstream, then the beta ratio is 20. Because 1,000 particles divided 1,000 particles upstream divided by 50 particles seen downstream, the ratio is 20. So beta 10 micron, is 20 because of the ratio between upstream and downstream. Where do we see this data? Hydraulic filter data sheets, and more on fuel filter data sheets. But what is the advantage of using beta rating instead of efficiency? Well, with today's engine technology using the high pressure common rail fuel system, ultra clean fuel is needed downstream. Downstream means fuel flowing to the fuel components, the highly sensitive fuel components. And only beta rating makes this instantly visible. With beta rating, the performance differences between filters is truly visible. But how does this work? I'm going to explain that on the next slide. In other words, the advantage is that with beta rating, we instantly see the improvement in removing the harmful contamination. In this example, we have 100,000 particles upstream, so the dirty side of the filter. Or we can also say 100,000 particles presented to the media. And to explain, downstream, the clean side of the filter, we have mentioned different numbers of particles, from 50,000 to 100 particles. And now we're going to look at beta 75 versus a beta 1000. So 98.7% and 99.9% efficiency. 98.7 equals 70, beta rating 75, and 99.9% equals 1,000, beta 1000. The efficiency difference between 98.7 and 99.9 is only 1.2%. So people think, oh, that's not a lot of difference. But with beta rating, what we will see is that a beta 1000 is 30 times cleaner downstream. So beta 75 versus a beta 1000 means that the beta 1000 is 13 times better, or actually 13.3 times better. Beta 1000 versus beta 20 means that the beta 1000 is 50 times cleaner downstream. So notice also that a beta 1000 is also meeting the ISO 4406 fuel cleanliness that I will explain a little bit later. But as mentioned, not all data sheets mentions beta rating. So there is a very easy formula to convert efficiency to beta rating, and that is what I'm showing here. So now, with having explained the particle size and the rating, efficiency and beta rating, The next slide is an example of real filter media performance, protecting sensitive equipment and minimizing downtime. And that is what we see here again, the ISO 4406 fuel cleanliness. There is this code 1296, real media performance meeting the ISO 4406 fuel cleanliness. Now, without me going to explain the ISO 4406 in depth, it is, I think, good to know that fuel system manufacturers like Bosch or Delphi or Denso or Cummins, also other injector or high pressure common rail fuel system manufacturers, are using this ISO 4406 as a standard. It's a standard fuel cleanliness code for modern high pressure common rail diesel systems. The number 12 here, the number 12, represents 4 micron particle size and also the maximum number of particles per milliliter downstream. So the clean side of the filter, the outlet, the fuel flowing to the sensitive fuel components. And I'm sharing here a part of the datasheet of a Fleetguard FF5782 NN NanoNet filter. And as you can see, this filter has an efficiency of 99.9% at 4 micron. So beta 4 micron, equals 1,000. This filter is meeting this important standard. Did you notice here the NN behind the filter part number, meaning NanoNet? I will come back to that in a short while. So what was the key takeaway of this part of the training? Well, efficiency is what the media captures, and beta ratio gives us a true indication of how reliably the filter protects. Beta rating is what reveals the real performance difference between filters. And that is actually the information you can use, you need to make the right choice. Now, with having explained efficiency, we have talked about beta rating, the differences between them, 2 additional subjects, and that is capacity and flow restriction. A 1-slide explanation. So capacity of a filter is the amount of contamination that a filter can hold, and flow restriction is the amount of resistance that an air or a liquid experiences when passing through a filter. Efficiency, capacity, and flow restriction are all the important topics, subjects to design a filter. And all filters have one thing in common, and that is filter media. So now we're moving into the heart of filtration, the filter media. So where is filter media made? Well, some filter manufacturers do manufacture their own filter media, but most filter manufacturers, they do not produce or manufacture their own media. Atmos, however, designs, manufactures, and tests our own filter media in-house. It's proprietary, and we do not make this filter media available for any of our competitors. So it's unique to Fleetguard filters. So what types of media are currently used in filters? I'm going to show you another video, which is an introduction to the types of media.
Filtration. down to the science. A filter is a filter is a filter, right? Maybe at a glance. So, what makes a filter different? It's what's on the inside that counts. The media, the stuff that actually captures the contaminants. Filter media must be tailored to the specific medium it's filtering. Providing the right media option ensures the highest level of performance and protection. Cellulose media with its larger fibers is effective at trapping larger contaminants. Microglass media's smaller, more uniform fibers increase filter efficiency and meets the higher performance demands of equipment. Melt-blown media's fine continuous fibers efficiently capture smaller contaminants, even down to the size of bacteria. Nanofiber's submicron, continuous fibers, provide an optimal balance of ultrafine and large particle removal, holding capacity, all without restricting flow. A filter is a filter is a filter if you don't care about longer engine life and lower maintenance costs. Fleetguard filters have unmatched media technology to protect your equipment and keep you going. Now that's a filter. Run cleaner, longer with filtration science.
You talked about common types of filter media. So we have cellulose, microglass, melt-blown media, and the nanofiber, and NanoNet nanofibers. Combinations of these media types are often used to improve performance. So from moving from the left to the right, the filter media provides greater efficiency, greater capacity, higher capacity, and captures more and more smaller particles. I'm going to highlight 3 types of media in the Fleetguard used in Fleetguard filters, each designed for a specific and exceptional purpose. Starting with cellulose. What you see here is a stacked disc filter media. It's the bypass filter part of a combination filter. Combination filter, it's called a combination filter because it's using a bypass filter and a full flow filter part in one filter housing, the combination filter. This type of stacked disc media is used on older engine platforms. But remember, a lot of them are still out there in the field and they are performing extremely well, as with the filters. As mentioned, this is the bypass filter part and it's called a combination filter, full flow bypass in one housing. It is the bypass filter that is a cellulose filter. It's designed to have a high restriction. That means that the oil through this filter will flow very slowly, capturing all that contamination. It's got a high sludge holding capacity and a high particle removal efficiency. The next media I want to show you is melt-blown media. Melt-blown media is fully synthetic filter media. We're going to melt down these pellets into a fluid and then spray it here on a rolling drum. Then these fibers are stretched and turned into a sheet. Melt-blown media is depth filtration media. It has continuous uniform polymeric fibers. It's got a high dirt holding capacity, high particle removal efficiency, 98.7% at 10 micron, for example, used in fuel water separators, and 30 micron for lubrication filters. An example of melt-blown media, multi-layer media, multi-layer media is Fleetguard's Stratapore filter media. Multi-layer media, as you can see here, layer 1, 2, 3, 4. And this media, each layer, is bound together by an ultrasonic welding process. We're not using a glue. We have multiple layers on top of each other, offer finer and finer filtration. So high efficiency, high particle removal, and the result of that multi-layer is that we have a greater contamination holding capacity. Each layer can hold contamination and also lower restriction than the previous media, the cellulose media. Many Fleetguard products are using Stratapore media. So watch for the logo, for the sign Stratapore on the filters, because then you know that the filter is using the Stratapore media. As mentioned before, today's engine technology, using the fuel systems, high pressure common rail, they need even better filtration. So why do we now need the nanofibers in our filter? And what is the difference between the traditional filter media and what is nanofiber? Well, contamination about 4 micron needs to be filtered out from the fluids. And that is what we already learned from the ISO 4406 explanation. So from multi-layer Stratapore media, we're now moving into the nanofiber media. Why do we need nanofiber technology? It's all about engine evolution, the high pressure common rail system, and also the different oils that we're now using. I'm going to use the high pressure common rail as an example. High pressure common rail is using very high injection pressures, and the fuel pump is capable of even producing higher pressures. We're looking at 3,500 bar today that a fuel system is capable of producing. So we have been talking about that 4 micron in the previous slides, and that is the fuel that is flowing downstream, the beta rating. And we're now looking at the clean side of the fuel system. High pressure common rail fuel systems are very sensitive to even the smallest particles, 4 micron particles. And we need to filter out as much as possible of these 4 micron particles. These particles accelerate wear inside the high pressure common rail, resulting in reduced engine performance, higher fuel consumption, and, worst case scenario, costly component damage. We're looking at 4 micron here, downstream 4 micron particles. 4 micron particle count here per milliliter. And what we see here is that NanoNet filters are already much better than the Stratapore filter, and much, much better than our the WillFit filters, the competitor filters. NanoNet is having the nanofiber media, and this media meets today's engine filtration cleanliness in transient engine operating conditions. That means that during engine vibration and flow surges, when the engine or engine equipment accelerates or deaccelerates. By looking at this graph, you'll notice that both filters, will-fit filter and the Fleetguard filter FF5782, are meeting the ISO norm, ISO 4406, the green line. When we start the test, both filters are meeting this standard, but soon, after a few minutes, we're going to introduce vibration here at this point. And then what we will see, or what we saw, is that the will-fit filter is starting to release contamination downstream to the sensitive fuel components, while the FF5782 NanoNet filter fully meets the ISO 4406 standard. And again, I'm sharing here that datasheet. 99.9% at 4 micron, so meeting the beta 1000, and it's a NanoNet filter. So Fleetguard tests, as you can see here, as I've explained, are designed to measure the contaminant removal efficiency of a filter during transient conditions, so operation conditions as in the field. So engine vibration and flow surges. Just like any filter would experience on an engine or a piece of equipment. What's the difference between NanoNet and the traditional filter? In this example, 3 to 5 micron size particles. You see here the cellulose on the left image have large pores. These 3 to 5 micron size particles will just flow through these pores downstream to the sensitive components, while NanoNet is capturing these particles, these small particles. Another point I would like to mention is that in technical bulletins or advertisements in literature, it is mentioned that filters do meet the parameters of laboratory testing. But ask yourself the question now, how many engines operate in a lab? So with nanofibers, nanofiber media, like the NanoNet filters, they hold contamination during the dynamic or transient engine operation conditions in the field with vibration and flow surges. Here you go. So how is that NanoNet fiber or that NanoNet media, the nanofiber, how is that made? Another video to give you an impression. So to give you a better idea about multilayer or the NanoNet filtration, I'm going to show you a animation, a computer-made animation. What we see here is the filter media, the NanoNet media, and the red and the green stripes is the NanoNet fiber. We have the upstream part of the filter, and we have the downstream side of the filter. So if I now remove the nanofibers, notice how the presented contamination upstream, so the dirty side of the filter, are retained in the nanofibers and with very few reaching the near bottom downstream. So NanoNet retains contamination in real-world conditions. So I'm sharing here the result of a field case study where injector claims dropped by 42% for Cummins using NanoNet filters versus non-NanoNet filters. So non-NanoNet filters and the NanoNet filters. Fleetguard filters made with NanoNet media provided 5 times more protection throughout the filter life. NanoNet products in our product range, we have the NanoNet fuel filters, NanoNet lubrication filters, NanoNet, so that is what we see here. Behind the part number NN means NanoNet, and with air filters we have NF, NanoForce. Key takeaways from this part of the training: the Fleetguard NanoNet media delivers higher efficiency, longer life, more stable protection, controlling smaller particles or small particles under real-world conditions. So it is our filtration science to keep the customer going, especially with more customers globally that are now pushing for biofuels as primary fuel source. And Fleetguard is very good at and highly motivated by analyzing customer needs and solving technical problems. Fleetguard can tailor-make filter solutions for specific customer applications. And that brings us to our next topic. What's on the horizon for the next generation media technology? So we have NanoNet Plus or the NanoNet 2. NanoNet 2 offers better protection, longer service intervals, and 10 times better particle removal efficiency. It has an excellent performance in poor fuel conditions. And the media on NanoNet Plus is no thicker than 1.35 millimeters. So that's very thin and very efficient. And NanoNet Plus stays efficient under vibration. So these transient engine conditions, the flow surges. And that is where the competitor filters are starting to release the particles downstream to the sensitive fuel components. Then another update for you is our NanoNet 3. It's our most advanced filter media. It has an advanced mesh media that gives a very high retention, so dirt holding capacity, and even a longer life. It offers unmatched protection, enables smaller filters. We can make the filters smaller and even with longer service intervals. It can be custom tuned for OEM needs, and also important, it uses fewer materials, so we are using less energy. It's better for the sustainability. Key takeaways from this part of the training. So from the NanoNet to NanoNet Plus, NanoNet 2 to NanoNet 3. Each generation raises the bar higher, efficiency, stronger beta rating, beta stability, and unmatched real-world reliability for maximum engine protection. If you want to learn more, go to fleetguard.com, the Knowledge Center. Fleetguard.com/knowledge center. You will find several topics. I'm mentioning four of them here. How does an air filter affect engine performance? The full filtration story you really want to know. Some interesting stories there. And why filtration matters. I really can recommend that part. And diesel fuel filter frequently asked questions. Something about warranty. Backed by the best warranty in the industry. Fleetguard warranty coverage is non-prorated. It's a peace of mind for anyone using our Fleetguard products. Go to www.fleetguard.com/warranty. Genuine filters. Channel partners for genuine Fleetguard filters. Buy genuine Fleetguard filters at our channel partners. Do not accept less than genuine Fleetguard filters. Look on fleetguard.com to find your channel partner. Contact and support. For EMEA, fleetguard.support.emea@atmos.com. For the UK, customerserve.uk@atmos.com, or contact your sales representative. This was also the last slide of this presentation, of this training. Now it's time for question and answers.
Thank you very much, Paul. In fact, we don't have questions so far in the Q&A box. So I would encourage everyone to please go ahead and write your questions down in the Q&A box that you can find at the bottom of your screen, and we would be very happy to answer them. So meanwhile, thank you, Paul, for this wonderful explanation about the media generation, and how the media shifted from cellulose to NanoNet. That was a great explanation. So meanwhile, I'm going to launch the feedback questionnaire poll. All right, so now you have the feedback questionnaire, and meanwhile, please continue to write down your questions if you have any at the Q&A boxes. We would really love to hear from you back about the feedback, about your feedback for the session. And Paul, maybe one thing that worth being mentioned, that Fleetguard is the only filter company that is producing their own, or our own, let's say, media, right?
Right.
So if we do talk about that, we might highlight that we know the need, we know the media, we know the market, and then we are producing the filters based on the requirement of the market. So this is a very good thing, and this is one of the things that is making always Fleetguard a leader in the filtration market.
Absolutely right. 100%. I see no questions. Am I correct?
Yes, I'm just trying to sort one thing. It should be through Q&A, not through the chat. So if someone is trying to send their question through the chat, okay, that cannot be done. That should be done through the Q&A box, not the chat box. Okay, I'm going to launch the poll again. Thanks, Rachel, for this. Okay, so the poll is being launched again for the people that weren't able to see the poll, the questionnaire, the feedback questionnaire. Meanwhile, we have a question poll. How can you see on the filter if NN3 or NN plus is used instead of NanoNet, a normal NanoNet? Is there any possibility to see that there?
At this moment, there is no not shown. So in the specification, it's shown, but not on the filter.
Okay, thank you for that. Okay, and thanks for the people that are following the feedback questionnaire and filling the feedback questionnaire for the time being. I would encourage everyone just to share their thoughts and their feedback through that. Meanwhile, the Q&A box is still open for your questions.